go over one thing that probably came up in your mind when we were going over the homework today. And that is if you looked at your structure for ozone, some of you guys probably noticed that your ozone structure looked different from the one that I had on the answer key. It probably also looked different from your classmates' structures. So this is a situation where there's more than one valid Lewis dot structure that can be written for a particular molecule, and this is called resonance. Now, a very famous example of resonance is with a molecule called benzene, and here we have, we can either draw the double bonds between the carbon atoms this way, so that the bottom two carbon atoms have a double bond and the two sides here have a double bond. Or we could draw it this way. Both of these ways are valid. So the real structure is actually an average of these two structures. And we would say each of the bonds, rather than being a double or single, is kind of halfway between a double bond and a single bond. Okay, so I'm going to draw on this slide how sometimes resonance is shown with benzene. So here we see that we have two different structures with an arrow between them, and that's what I want you to do. But if you look online, sometimes for benzene, we'll see that we have carbon, and we'll have the 6 carbons with the hydrogens around it. And what you see is you see the single bonds between the carbons and the hydrogens. And you see a single bond between each of the carbons. And rather than drawing alternating double and single bonds, sometimes what's done is the second bond here will actually be a dashed line, showing that it's kind of halfway between a double and single bond. So each of the bonds is like a 1.5 bond. So what we see in nature is that the true structure is halfway between those two structures, and this is one way it's represented. Another way it might be represented online is that you might have your carbons with a single bond between each carbon. And then, actually, let me fix that. And then you have the hydrogens off of the carbons. And then you have a circle here showing that the electrons are kind of being shared between all those carbons. So those are just different ways resonance is shown with benzene. But like I said, on the worksheet you're going to be working on, I want you to draw all the possible structures and put double arrows between them. Okay, so I want to show you also ozone. Ozone also exhibits resonance. So what we say is neither structure is correct. The actual structure is the average between them. So that's how that's shown. Okay, so now I'm going to pull up your worksheet you're going to be working on. And this is under classwork. So you're going to be drawing all the possible structures for your, to show resonance and putting double arrows between them. One thing I want to point out here on this sheet is that number 3, when you see the word cyclo in the name, this is actually telling you that you have a ring. So that is a term in organic chemistry. This "ene" at the end is also telling you that you have a double bond in your structure. So when you see the "ene", and di means you have 2 double bonds. So that's going to give you some hints as to how your structure should look. So I want you to try these 4 problems. Sometimes there's going to be more than 2 resonance structures. There can be many resonance structures. So I want you to keep that in mind also. And then let me know if you have any questions.